Last time, we asked Mr. Sensible why he decided to name his balloon satellite MAGE. It turns out he was able to answer that for us. When I think of mages, I think of wizards, magicians, and magic tricks. The dictionary definition of mage is a magician, after all.
It is in some dictionaries, in others, it's a magician or a learned person. It's just fun. It is an acronym. Don't get hung up on it. It's nothing to do with magic. Okay?
He named it Mage because mage meant a learned person? Maybe at Hogwarts it does. Sorry, I have a hard time believing he named his balloon satellite Mage because he was thinking of a term for a learned person. Although, perhaps this is a term that falls in the culture gap between the Americas and Europe. After all, when I think of the term snogging, kissing is the last thing that comes to my mind. So maybe this is one of those things. But I have my doubts about that. Now, I should also mention here that Mr. Sensible doesn't consider his device to be a balloon satellite.
And I'm assuming it's a slip of the tongue. It's not a satellite, it is a balloon. A satellite is something different. But okay, let's carry on.
I certainly think it resembles a balloon satellite. This makes me really wonder how he distinguishes the two from each other. Alright, so in my last video I took 5 screenshots from his uncut mage footage and carefully analyzed them. Please allow me to share his responses with you. We'll start with his responses to that first picture at 3,000 meters.
Well, yes, that is pretty much slap bang in the middle, thank you. But 3,300 meters is not high enough to show the curve. Not high enough at all. Which is why when we come to results, I didn't use any heights as low as that, but okay.
Here I have taken a straight line across the horizon, and it looks pretty flat. Let's take another shot from a higher altitude and see if that changes.
Oh, okay, I take back what I said. That's fair enough, you're just doing comparison. Carry on.
Hooray! Mr. Sensible appeared to acknowledge that this horizon appears flat. Ooh, just a little over 11,000 meters now. Let's put a straight line across that. Alright, so as I drag the line across the horizon, I see that the atmospheric gradient is so strong it is difficult to see where I should put the other end of the line.
Absolutely, which is why even at maximum height it was actually quite difficult to find shots that you could have any clue, sort of sharp edge clue to draw lines to, because a lot of it is blurry, which makes things very difficult, and you've obviously acknowledged that. My goodness, we're doing well so far, mate.
Let's adjust the brightness and contrast of this picture to see if that can't sharpen the image and make things easier. I don't even have to draw a straight line across this. I fully acknowledge that I can see some curvature.
Wow. Thank you, Kyle. You're right. It's absolutely obviously some curvature. Whatever the cause, there is curvature, which makes a massive change from a lot of those flat earthers who are just denying it and saying, no, that looks straight to me. So thank you for that.
Wow, he is celebrating our common ground here as well. This makes him really fun to talk to. Now my question is this the curvature of the Earth that we are looking at? Well,
I'm not really sure what else it can be. Let's give it a crack.
What I'm going to look for now is if this is the curvature of the Earth that we are looking at. I expect it to have about the same amount of curvature all the way across.
Before you look at that though, Kyle, it surely either has to be one of two things. The curve of the Earth or distortion. Look at the line. There's the upper line there. There's the lower line there. How could something that's straight, flat, in between those be curving more than either of those lines? Remember that barrel distortion chart. Across the middle is where you're going to get no distortion. So why is it curved? Let's let you carry on.
Well, my question is the center of those two lines the center of the lens? Just having two digital straight lines running across your HUD doesn't prove anything about where the center of your lens actually is. He could just be zooming in on his actual video and only be showing us the bottom half of his video. But let's continue on under the assumption that he is not doing anything underhanded here, and that this is actually the center of his lens. With that, I agree that this probably isn't lens distortion. I want to mention here that if he did fudge the footage, he already knows it's flat, and there was no point in arguing with him. But if he didn't fudge the footage, then I think there's value in continuing on with this. And I really do think he's sincere about this, so I'll continue on. If the right side curves faster than the left side, that is where we're going to bump into some problems.
Are we?
Let's do MC Toon's scrunched horizon trick to check out the curvature of this.
It's not just MC Toons, lots of people do it. But I'm glad you're putting that yellow line along there. Okay, let's see what happens.
Alright, here I'm going to go ahead and select all of that, and then we're going to scrunch it really quick. Select. And scrunch.
Oh dear.
Yeah, that right side definitely doesn't have the same amount of curvature as the left side does.
But have you noticed that straight yellow line, although the angle has changed, remains straight? And I'm not quite sure why you have a problem with the amount of curve there to there. Remember this straight line, the angle has changed. So you think with a curve, the angle's changing all the time. When you scrunch it, you're changing it again. More on that in a while.
And another interesting thing to observe is the center of our curve isn't the center of our photo. I wonder why that is. I understand Mr. Sensible's camera was rocking back and forth and wasn't always level, so let's rotate this and level it out. If that's the curvature of the Earth, that looks pretty lopsided to me. Let's try this again at just over 15,000 meters.
Very blurry image there though, Kyle. I would hope that there's some better ones that you could have picked.
Okay, let's adjust that brightness and contrast. And we'll check to see if our line is where it's supposed to be. Okay. I do see some curvature there.
Good.
Let's go ahead and scrunch that and do our scrunched horizon trick. Look for the same thing. Scrunch. Huh. Well, that's interesting.
Is it?
We don't see the same amount of curvature as we did in the last picture.
It depends on what you're looking at.
That right side looks a lot flatter than it used to. What's going on here?
I think, with all due respect, Kyle, what's going on is you're not quite understanding what happens when you scrunch the picture left to right. Scrunch.
All right. So here at 15,000 meters, Mr. Sensible doesn't appear to acknowledge how the horizon appears half curved and half straight. He just said he doesn't think I understand what happens when I scrunch the picture. I've got to mention here how on my debate board, the argument "you don't understand" has been ruled out as a dead argument. When a person makes that claim, they imply that they know more about the subject than their opponent does, and that makes them right. Just because someone doesn't understand something doesn't mean their claim is wrong. And just because someone knows more about something than someone else, that doesn't mean their claim is right. This falls in line with the genetic fallacy because it's judging a claim to be right or wrong based on the person who made the claim. It also falls in line with the ad hominem fallacy. Rather than explaining how or why a person is wrong, they're just attacking a person rather than their argument. Herein, they're just throwing insults, which is counterproductive. Alright, let's go even higher. 25,000 meters. Will it get flatter or will it get more curved? All right, brightness and contrast. Check in our line to make sure it's accurate.
I'm just going to pause you a second there. No fault of your own, but over here, just due to the colours of the shadow of clouds and non-clouds and so on, you've got the horizon line. I'll call it a line, not straight, not curved, but you've got that horizon there, which gets cut off purely because of the background colours. So you've not really got a full width to play with, but you know, that's not your fault.
All right, let's do the scrunched horizon part.
Let's. Oh, okay, you've just taken that part. Fair enough.
Scrunch. I think it's interesting how Mr. Sensible is 100% convinced that this proves the Earth is a globe.
Well, what you've got to remember, Kyle, is that camera is a narrow angle camera. We have got a narrow field of view, so you're not going to see much curve. Then, in this case, we're actually using less of it. So I would have to say, probably best to use a different image. Okay, I'm not saying you've done anything underhand, but that's probably not the best image to use to try and show anything either way.
Here, let's put a line across that just because.
That's a waste of time.
Now I think it's interesting how even though the balloon went higher, the line got straighter.
You're putting a straight line.
Now let's try
there.
this again with the highest altitude.
You're putting a straight line there along an image that you've already manipulated, so that's not a fair test anyway.
So it seems like he is saying, as long as it's curved, it's a fair test. But so long as it's flat, or even halfway flat, he either doesn't want to acknowledge it, or he claims it was an unfair test. Excluding the first image here at 3,000 meters, of course.
That's not a fair test anyway.
Of just over 37,000 meters, and see what we get.
That's more like it.
Okay, go adjust that brightness and contrast. And we got a blip there. Looks like it's coming from the lens flare.
Yep, lens flare, definitely, I agree. Now, just ballparking that by eye, can you not see the curve?
All right, let's do the scrunched horizon part. Scrunch. Zoom in on that. Now I do see some curvature.
I am honestly really, really glad that you've acknowledged that throughout. That is excellent.
But the question is that the curvature of the Earth that we are looking at?
Well, you would have to posit an alternative explanation. We're photoing the Earth, or videoing the Earth. We can see the Earth. The Earth looks curved in the image. Therefore, without an alternative explanation, I would say that's because the Earth is a sphere. The only other possibility that I'm aware of is distortion, but we have ruled that out by using imagery across the sweet spot, as you so aptly put it, across the centre of the screen. We've also got the reference line strings, because if the Earth is being distorted, the strings would be distorted, and this does not correlate with any bending in the strings. So therefore, without an alternative explanation at this point, I would say, yeah, it's the curve of the Earth.
Man, if that is the curve of the Earth seems to be continually changing shape, flopping around like a floppy pancake in the air. Alright, so if this were the curvature of a globe Earth that we are looking at, I would expect to see the horizon start out looking relatively flat, and then gradually become more and more curved the higher we rose in elevation. And I would expect to see even amounts of curvature throughout each photo. But here I'm seeing all kinds of inconsistent curvature. If that were the curvature of a globe Earth, the Earth would be rapidly changing shape, and I would think we would notice that on the ground if that were the case. Now, Mr. Sensible also mentioned the other possibility of lens distortion here. If it were lens distortion, I would expect to see a pretty consistent amount of curvature in each photo. The horizon should not have appeared flat at 3,000 meters, nor should it have appeared flat at 25,000 meters. Mr. Sensible is pretty insistent that it is either the curvature of the Earth or it is lens distortion. I'll entertain those two options for another moment here. we aren't exactly looking at solid ground here. We are looking at clouds, and clouds are very much known for changing shape. That could explain why we are seeing varying amounts of curvature in each photo. On the other hand, with our other option being lens distortion, I have to wonder if we have an autofocus going on here. Mr. Sensible did mention that some images were blurrier than others. Maybe that is because the shape of the lens is changing. But what about the two straight lines? Why aren't they distorted? Are they physical strings that are taped across the camera lens? Or are they just digital lines on the HUD, like the meter on the right here? Sorry, it's a MAGE thing. When he named his project MAGE, that got me looking for some kind of Carbonaro effect. I'm doing my analysis based on the inclination that he is being sincere. But the possibility of him doing a sleight of hand still weighs on me in the back of my mind somewhere. But on closer observation of the two lines, I do see shadows on the top line here, as well as the sun lighting it up from time to time. So that gives me some confidence that it is an actual string, and inclines me to believe that he is not just pulling my leg here. With that being said, I lean towards the first option, that these effects are not caused by camera distortion, but that these are actual effects on the horizon that we are observing. Now, Mr. Sensible has some more commentary, so I'll let him continue with that. Let's compare Mr. Sensible's footage with this picture of the Earth supposedly taken from space. Here I'm selecting the photo. Now please notice how, as I rotate the photo, the center of the curve always remains about the center of the curve.
Yeah, and why? Because you have the center point of that circle. So yeah, the edge is equidistant from that center point, so it's always going to be a smooth rotate. Now if you took and rotated about that point there, it's not going to, you're not going to have the same effect, are you? You're going to get a circle that swings around like that. So I'm not quite sure what you think you're showing there. And of course, with this photo, you're able to actually locate the center of the diameter of that Earth. On my imagery, you're right up close to one edge. You have no hope of finding the center point to rotate around.
All right, let's move that anchor point and test out what he said. All right here, the center of the curve appears to be the center of the screen here. Now I'm going to rotate that. The center of the curve still seems to be about the center here. Let's rotate it the other way. Oops. Rotating it the other way. The center still seems like the center. Nothing's changed. What I'm saying here is, with that apparent picture of the globe, we don't get any kind of this weird lopsidedness going on. All right, now we're going to do the scrunched horizon thing. Scrunch! Now as we zoom in on this, please notice how there is even amounts of curvature on the left and on the right.
Yes, there is. Down here, this curve mirrors this curve. However, the curvature shown here is different than the curvature shown there. It depends on the angle. Here, the surface of the Earth is close to vertical, so it's just being pushed to the left. Here, the surface of the Earth is close to horizontal, and so it's getting more distorted. You've just shown why you can't use the amount of curvature in a scrunched photo to prove anything other than that surface was not straight in the first place, i.e. you have accentuated the curve. Remember in that photo you scrunched up that had the yellow line remained straight. It did not curve to any extent whatsoever.
Yes, I acknowledge that when I scrunched the photo, I changed it from a circular image to an elliptical one. Therein, after scrunching the image, I wasn't looking for equal amounts of curvature throughout the entire photo anymore. I was looking for this mirror effect. I expected to see the peak of the curve in the center of the screen, and I expected to see the left side mirror the right side. But my observations are not consistent with my expectations of what things should look like on a globe. And that is why I have a problem with believing the claim that we are looking at the curvature of the Earth here. I shared our globe picture here as a standard to judge our other photos off of. If the other photos were of a globe, I would expect similar results.
Oh, thank you, Kyle. Put your word to the test. Yeah, thank you, Kyle, for tackling my video. I really appreciate it. Obviously, I think you're wrong. I know you're wrong. I'm going to show you why with regard to those scrunch curves in just a second. But that was a decent attempt at a debunk. So, cheers. Right, let's have a look at a load of balls. So here's a size 5 Dunlop basketball that some kids have lobbed into my garden. Let's scrunch it. There we are. An image that pretty much equates with your image of the Earth taken from space. Excellent. Now let's have a close-up, just part of the horizon, and scrunch that as well. And we'll do yet another one and scrunch that. Now what have we got? Well, this was just quick and dirty, but you see, you get very different curves depending on the angle that the curve is crossing your field of view. You can try it yourself, just get a ball and take numerous photographs and scrunch them. It's quite obvious, really. So there we go, Kyle. It depends which part of the sphere is crossing the screen when you scrunch it down as to how that curve appears.
Alright, so taking a look at this ball, I can see that the peak of the curve is in the center of the curve, and that the right side of the curve appears to mirror the left side with equal amounts of curvature. Alright, so let's go ahead and scrunch that real quick and check it out. Zoom in. Alright, now let's go ahead and level that out here. Interesting. Now the ball appears to have uneven amounts of curvature on both sides, and it appears lopsided. That very much reminds me of this image here at 11,000 meters. I can't say I was aware of this observation when I made my first video, so I'm totally learning something new here. And science is all about learning, so this is a good thing. Now, with this ball representing a control in the experiment, I've got to say that my expectations have changed concerning what should happen if I were to scrunch an image of a globe. With that being so, our picture taken from 11,000 meters now checks out with our control. But what about our half-curved image at 15,000 meters? And our flat image at 25,000 meters? Do those check out with our control? I don't think so. You're going to have a hard time trying to convince me that those were caused by tilting the camera in a special way. Please note, I still have the expectation that if it were the curvature of the Earth that we were looking at, it should start out looking relatively flat and then gradually appear more and more curved the higher we rose in altitude. But that isn't what we observe, so I can't conclude that the curvature that I acknowledge that we are observing is caused by the curvature of the globe Earth. Now again, to be very clear, I don't think the curvature here is caused by lens distortion. I believe these are actual curves that we are seeing in reality. However, I'm still not convinced that we are seeing the curvature here because the Earth is a globe. So here's the question. If we're not seeing curvature from a globe, what is causing the curvature? Here is my hypothesis and my flat Earth model prediction. My hypothesis is that the curvature we observed in the MAGE footage was not being caused by the Earth being a globe, but instead it is being caused by the sun's radial light reflecting off the cloud tops. Now I'm going to put that hypothesis to the test. Get ready for this. Please keep this in mind while I'm at it. I think my hypothesis does a much better job at explaining how we're seeing inconsistent amounts of curvature here in each photo. Let's take another look at that curved horizon at 11,000 meters that just barely checked out with our control image. Here we are, 11,000 meters, unaltered, straight from Mr. Sensible's video. Alright, let's put an arrow at where we think that horizon is. Right here, right? Alright, let's go ahead and change the brightness and contrast and see what happens. It went up. Look at that. Whoa. It's really going up there now. Think I can get to go black and white from way up there? Oh, look at that. That horizon is moving all over the place. Why is that happening? Still, the horizon looks like it's up there, right? What's going on is it's that light reflecting off of the clouds. Please also notice here how this horizon appears generally flat. But all of a sudden, as we change that brightness and contrast and raise it up, all of a sudden now it's looking curved. All right, so that's two confirming evidences. Now here's a third. Please watch how, as I adjust the brightness and contrast, not only do we see a curve up here, but we also see a curve down here. You see that? Here's that curve right down there. Make it really clear all of a sudden. Yeah, you can definitely see that curve. And the whole reason why we're getting that, it's because of the sun's reflection off the cloud tops. So that is three confirming evidences that the curvature that we saw was not caused by the Earth being a globe. That also explains how you can see curved horizons on a flat Earth. And that, my friend, is what science with an emphasis in art looks like. A special thanks to Mr. Sensible. You've brought some new things to my attention that are going to require me to go back and rewrite some of the curriculum in the Flat Earth Institute of Science. So thank you for that. And thank you all for watching.